All right, guys. So, week 7, video notes, lesson 2, right? Um, so we're back into transformations. This is something that I've told my students never to let escape their head. Don't forget about transformation rules and transformations because it's going to continue to pop up until the end of the year. And it'll even pop up in your future math classes, right? So, if you do remember those rules, today's going to be pretty much a walk in the park, piece of cake, right? If you don't, then you definitely need to get a refresher on it. That's what these quick reviews are for. And then if you need those rules in front of you, like we've taken notes on before, maybe you don't have those notes anymore. I told you a couple weeks ago that you can go onto Google and search algebra transformation rules, and all those things are going to pop up for you right there, right? So make sure you use your resources wisely. Get those notes taken care of, and you should be just fine. So without further ado, guys, let's go ahead and get this quick review done and out of the way. Make sure we're all on the same page. I'm going to go ahead and put this in a medium in which we can all kind of get behind and understand. It's just a little bit of slight work for me, so no big deal. Video notes week 7. Transformations crank it to 11. Square root of x minus 2 and minus 5. Easy man, no matter how you spin it. I'ma show you how to get it. Minus 2 inside, slide to the right. That's 5 outside, going down green light. Basically I'm saying that subtract, we gon' slide if it's in or outside. Yeah. Let's see these graphs move around for us. I can show you transformation, spreading math across the nation. And you know we out here every day with it. I'ma show you how to get it. Negative outside, flip across x, 3 outside, vertical stretch. Can't forget about adding on that 7 inside. To the left it's gonna slide, yeah. Catch my breath real quick. Oh, I'm not done. Mr. Garrett in this thing for no reason. Math, yeah, that's what my expertise in. Last question, talk about how to begin. High five, man, we really got some skin in it. I'ma show you how. Negative inside, flip across y. Half outside, vertical shrinkify. Can't forget about adding on that 1 outside. To the sky it's gonna slide, yeah. Woo! There it is. Little Tuesday slide. Graphing radicals for you. Hopefully that helped out just a little bit. If not, then I just embarrassed myself for nothing, right? So let's kind of get serious about this, guys. Make sure that we're understanding. Sketching these graphs, hopefully you guys have a really good idea of what these look like. We've talked about these in the parent function unit. We've talked about these plenty of times. So that the square root of x, this first one, that's a horrible xy plane, but it's okay. Remember, it starts at the origin, and then it's going to go up and kind of steady off. Remember, that's because, it's never going to be negative because you can't take the negative square root of something. The square root of a negative number is what I meant to say. That will give you an imaginary number. Remember, this is just in the real plane. The square root of negative 9 is 3i, and this is not, we have nothing imaginary here. This is a real Cartesian coordinate plane. All right, so as we move over here, we know that we can have a negative number. We can take the cube root of a negative 8. A cube root of a negative 8 would be negative 2. So negatives are okay over here. So it's going to look just like that square root, but it's also going to come down into this negative realm and kind of fade off that way. Okay. What's important before we start, guys, this is going to look very similar for any even root. Any even root is going to look just like the square root of x. Now, it's going to flatten out a little bit faster. It's going to be a little bit squished, but that's okay. The basic shape is the same. And same thing for over here. Any odd root is also going to look the same there. Any odd root is going to be just fine. It's going to look the same. It's going to be a little bit more squished, but the basic shape is the same. So those are the only two we really need to know in order to continue on. So when we come down to number 1, again, guys, if you know your transformation rules, it's going to be a piece of cake, walk in the park, right? So what it's asking us to do is state what transformations are taking place from f of x to g of x, and then provide a quick sketch of the graph to show what those transformations look like, just to make sure you can apply those transformations to a coordinate grid, right, to make sure you know what it's going to look like, okay? So let's get started, right? So first of all, what's the first thing you see? Well, the first thing I see is this plus 2 in the middle there. Inside, on the inside, right? So what is that going to do? Well, if I add 2, inside. That's going to be moving to the left 2 units. And I'm going to write units over here. So it's going to go to the left 2 units, right? And that's going to be perfectly fine, right? And then what else do we see? Well, we see that -1 on the outside. So minus, and I'm not going to do this tedious the whole time, guys. This is just to start. So -1 outside. That's going to be shifting down 1 unit. And then lastly, what's easy to overlook, and I hope you did not overlook this, is this negative out front. I know it's kind of weird seeing it so close to that equal sign, and some of us may overlook that, but just make sure that you're paying attention there. That negative on the outside. So negative. Notice that we're not subtracting anything with that negative. That negative is just kind of attached to it. It's making everything else negative. So on the negative outside, I'm multiplying everything by -1 there. That means I'm going to reflect over the y-axis. Oh, the x-axis. Sorry. Even I sometimes will get a little bit confused. So I reflect over the x-axis, right? Because all my y's are going to go from positive to negative. So that's flipping over the x-axis, right? So I'm going to apply all of these, right? I'm going to go ahead and apply all 3 of these things. So first, I'm just going to give me the sketch of my parent function, right? So I'm going to go ahead and sketch the parent function, start with the origin. And remember, any even root, so this is the 4th root, any even root is going to look just like that square root parent function, right? Nothing much is going to change. It's going to be a little bit more squished. Remember, I don't care if it's a little bit more squished or not. As long as the basic shape is okay, then we're good. And I'm going to go ahead and just sketch this. So I'm going to grab another, let's grab pink. And so I've got to move this origin to the left 2 units, 1, 2, down 1 unit, 1, here. And instead of sketching up here, I'm going to have to reflect it over the x-axis. So instead of going upward, it's going to come downward. Right, kind of like a sideways parabola I've just made there. But so that's going to be my graph. So I'm going to just graph that over here. So I'm going to start about right here. And then I'm going to go downward instead of upward. And there it is. There's your sketch of the graph. Right, pretty simple. Pretty simple. Okay, so yeah, seems pretty simple, right? Again, if you know these transformation rules, this is going to be very easy for you. And if not, just make sure you're reviewing these transformation rules, making sure you're getting this. Okay, now we got an odd root, right? We got a 5th root. It's going to be odd, so now it's going to look like the cube root function when we do it. But first and foremost, let's make sure we're listing these transformations that are happening, right? So the first thing I see is this add and subtract. So always do the add subtract first. It's going to be really easy to do. So if I'm adding 5, that means I'm going to go up 5 units. Remember, I'm adding 5 to the outside, so I'm going to go up 5 units. Then I see this 1/3 on the outside that I'm multiplying by. So remember, that's going to be a vertical compress by a factor of 3, or by a factor of 1/3, however you were taught. I'm just going to write vertical compress, because remember, this is just a quick little sketch, guys, so no big deal. So I'm going to go ahead and draw this parent function again. So this one's only having 2 things happening to it, which is really nice. So again, I'm going to just sketch this odd root function. So it's going to look like a square root, but then it's going to come to the bottom here. Oops, sorry. And then, so that's about a rough estimate. Then I'm going to take the pink again. I'll stick with pink, right? So I'm going to move it. This is supposed to go through the origin. That's okay. So I'm going to move it up 5 units. So 1, 2, 3, 4, 5. And then I'm going to vertically compress it. So it's going to be just a little bit more skinny. I made that skinny already, like a dummy. But it's okay. So I'm going to just make it really skinny just to get across that, hey, this is going to shrink. Right. So then I'm going to come over here and really sketch that out. And that just looks horrible, but it's okay. So then I come up to 5 here. And again, I'm just going to make sure it looks really shrunken vertically. Almost like a straight line. It's not going to be quite that compressed, but again, you're just getting the point across that you know it's going up 5 units, and it's going to be vertically compressed, right? So that's my new graph there. No big deal, easy peasy, right? Now coming down to number 3. This one is, so this one actually gets some people. I think once you see it, it becomes very clear, very simple, but just getting to see it is the tough part. So I've already kind of gone over this with some of my classes, or all my classes, and again, it took them just a little bit to understand, but I think once you get it, you're going to be just fine. So let's talk about this. So write the new equation for g of x, meaning my g of x here is in terms of f of x. That's not what I want. I want a whole new equation for g of x. So I'm going to take whatever f of x is and apply whatever I'm doing to it in here and create a new equation. So let me show you what I mean. I know my f of x is 1/2 times square root of x. But then I see that f of x minus 5. I'm going to subtract 5 from x on the inside of the function, from the domain, right? So in those parentheses, like you know that from transformations, when it's in the parentheses, it's affecting x. When it's outside the parentheses, it's affecting y. You can put things inside or outside that square root symbol. None of that is news to you, but it is just a little bit different way of thinking. So let's continue to put our answer in pink here. So my g of x is going to be f of x, right? This is all in terms of f of x, this is f of x. So let's go ahead and write that f of x. It's going to be 1/2 square root of x. That's your f of x part. But I have to add that negative 5 on the inside. So I'm going to just extend that. Remember, it's in the parentheses. That means it's going inside the square root symbol. I'm going to extend that square root symbol and just say, okay, instead of an x there, I'm going to have an x minus 5. And that's it. Obviously, it gets a little bit harder than that. That's a really easy one. But really, as long as you can see that, hey, I just apply this to f of x. So I take f of x, which is 1/2 square root of x, and then I do whatever my alteration is of minus 5 from the inside. I'm going to put that on the inside, and voila, I'm done, right? So let's try this a little bit tougher one down here, number 4, and hope we can get it that way. Okay, so here I have f of x being a longer one, right? It's 7 square root of x plus 3, and then a minus 2 on the outside. And my alteration is going to be a little bit different, so this is going to be a little bit more tough. I have a negative on the outside of the whole function, right? That negative is outside the entire function. F of x is sitting right there in the middle, and these things are being done after the fact. So I'm going to have a negative on the outside, and I'm going to add 4 on the outside of f of x. Notice how I haven't done anything inside of f of x. F of x sitting right here is unbothered. It's by itself. It's just chilling, right? Nothing's happening to it on the inside, all on the outside. So that's what I'm going to kind of do here. So let's go ahead and write this f of x down here. So g of x equals, and I'm going to write this f of x first. So 7 square root of x plus 3 minus 2. And then these things are going to be happening to the outside of it. So let's go ahead and switch back to red. And I know that negative is outside of that f of x. And I also know I'm adding 4 to the outside of that f of x. So notice, hopefully this starts to really become clear to you. Notice, this, I'm going to underline this, this is just this. All we did was substitute what f of x equals in for f of x, right? So we have the f of x here. We have a negative out front, outside of it. That's what we have here. We have a positive 4 on the outside of it afterwards. That's what we have here, right? Very simple. Then what I can do is grab that and solve this. Now it just becomes distribution and combining like terms. This is something that we can all do, right? So I'm gonna distribute this negative. I'm gonna distribute. I should write that in red. Distribute this negative here to there and there. So I'm gonna get a negative 7 square root of x plus 3. And then I'm going to get a positive 2 because I'm just changing the signs of those. And then I still have that positive 4 on the afterwards. So I can combine these like terms here, these two, and that just ends up being plus 6. So my final answer, and I'm running out of room here, I can come over here and write it. So my final answer, let me do this really quick. So my final answer is going to be 7 negative 7 square root of x plus 3 plus 6. And that's it, right? That's it. So, there you have it, right? That one actually does get some people, right? It can confuse a little bit. So make sure that you're understanding that. Make sure you play that back a couple times if you need to. And it's just a bunch of substitution, and that's about it. Okay. So, otherwise, that's about it. Like I said, if you know those transformation rules, you're going to be just fine on it. Just make sure you're refreshing your mind on that. And hopefully you guys are having a great week. If you have any questions, go ahead and contact us, email. We're available for tutoring, whatever the case may be. All right? So have a good week.